Hello again, this is Miriam. So this time we are going to talk about the differences between the AMD Athlon, Ryzen 3, 5, 7, and 9, and the Threadripper and the Threadripper Pro. So let's focus our attention to the AMD's powerful processor architecture built on Zen technology. So by the end of this video, I hope you'll be able to see the distinction of those mentioned processors. So, and let you understand that it's more than actually just a core count. So let's start with the Athlon. So this Athlon is actually a purely budget focused processor. It is ideal for light office work or a family browsing PC. It is often features integrated Radeon graphics, which means you don't need a separate graphics card for basic display. So the Athlon brand represents the foundation of the AMD's offering, focusing on maximum budget efficiency. The second that I'm going to tell about is about the Ryzen family. So the Ryzen family is particularly built for the consumer and enthusiast. So the Ryzen family is where most modern desktop and laptop sales live. It scales cleanly from essential function all the way up to the extreme performance. So moving into the numbered series, the Ryzen 3 is your starting point for a modern PC, offering a strong 4-core performance for a light gaming and daily tasks. The Ryzen 5 is the consensus performance sweet spot with 6 to 8 cores, it's arguably the best value for mainstreaming gaming and general content creation, providing ample multitasking power without the flagship price tag. So the Ryzen 7 actually targets high performance computing. It is an 8 to 12 cores that are perfect for heavy workflows like dedicated streaming, 4K video editing, and running professional software smoothly. Finally, the Ryzen 9, which is the flagship consumer chip, it pushes up to 16 cores, intended for prosumers who actually need the absolute fasting rendering and compilation times possible on the standing desktop motherboard. So the Ryzen series of AMD is primarily for consumer line, offering a clear performance hierarchy for laptops and desktops. Now, what are the key differences in the Ryzen series? As you can see, this is a visualization of the core counts and features availability across the mainstream Ryzen family R3 to R9. So this comparison table clearly shows how performance scales. The most important trend here is the direct increase in the number of cores and also the threads. So as the tire number goes up, so more threads is directly translate to faster parallel processing. At a crucial point, however, in the memory channels, the entire consumer Ryzen line from 3 up to 9 uses a dual channel memory configuration. This is a standard for consumer machines. Also, note that the graphics availability, like the G series, Ryzen's chips are APUs or accelerated processing units, meaning they include capable integrated graphics. If a chip doesn't have a G or an X in its name, particularly at the Ryzen 9 level, it usually requires a discrete graphics card to even display an image. So actually, regardless of the tire, all modern Ryzen chips are built on the efficient Zen architecture, giving them a strong foundation for performance. So when you outgrow about the Ryzen, you move into the specialized world of Threadripper. It is designed for maximum parallelism and data throughput. So the first one is the standard Threadripper is for the extreme prosumer. It scores up to 64 and crucially introduces the quad channel RAM support. It is twice the memory bandwidth of the Ryzen. It also provides a high number of PCL lines, around 80s, for multiple GPUs and NVMe SSD, making it a dream for independent professionals who rely on rendering speed. The ultimate chip is the Threadripper Pro. This is built for enterprise and certified workstation. It pushes core counts to 96 plus and offers octa-channel RAM support, actually effectively doubling the memory bandwidth and capacity again up to 2 terabytes. So the Pro designation also means ECC memory support. It is crucial for the data integrity and the maximum number of PCIe's Gen 5, which is actually 128 plus, supporting actually huge input and output expansion and security features required by major corporations. So Threadripper, the workstation powerhouses, is designed for massive parallelism, extreme I/O, and specialized professional workflows. So looking at this slide, which is the consumer versus the professional summary, we can actually see the architectural divide of the AMD tires from Athlon to Threadripper Pro. This is a comparison of the budget Athlon and the consumer Ryzen platforms against the professional workstation platforms, which is the Threadripper and the Pro version. So this final summary actually lines into your perspective and highlighting how this segment on the market based on your architectural differences, not just core count. So on the far left, you can see the Athlon chip. Its primary focus is simple, budget, and basic tasks. It offers 2 to 4 cores and minimal expansion capabilities. Moving on with Ryzen 3 up to 9, the focus shifts to speed per core and gaming. So these chips cap out at 216 cores, but actually utilize the consumer standard of dual channel memory. Finally, the professional tires, which is the Threadripper and the Threadripper Pro, are where true scalability begins. So this steps up the quad channel memory and higher core counts for prosumer rendering. So the Pro alone with a octa channel memory is a massive PCIe lane and ECC's RAM support. So this is the choice when stability, scalability, and enterprise grade security are required, making it the highest end solution AMD offers. So that concludes our look at the AMD processor from Athlon to the Core Threadripper Pro that AMD actually offers a chip tailored for virtually every compute needs. Credits to the following resources. See you again next time. Bye.